Okay, this video we're going to deal with how to graph a quadratic in vertex form and find the characteristics using vertex form. This is a little bit easier, I think, than standard form. And the last two, finding the point symmetric to the y-intercept and the x-intercept, you do the same way as you did with standard form. Once again, I'm going to be going back and forth, and we're going to be using example B on this page, okay? So on example B, it says 2x plus 1 squared plus 3. To find the vertex, if you look on your other page, it says it's h and k. When it's in vertex form, this is what you find first, okay? And so you're going to look at this and you're going to say, okay, well, it's going to be -1, comma 3. Now the reason it switches is because this actually, if you think back to our transformations, that actually means to go to the left 1. Okay, so your vertex, it would make sense that it's -1 and 3. Your axis of symmetry, you just look at this, and your notes say that it's where x equals h. So whatever this value is, which is -1, you just write that down. So these we don't have to do any calculations. When it was in standard form, this took a little bit of time. You had to do -b/2a and then evaluate it in and get the answer. When it's in vertex form, so when you have parentheses and then quantity squared, this is how you work it out. To find the y-intercept, in this form, this is the hard part of the question, okay? Because you actually have to plug it in. Now remember, this is, you plug 0 in, and then you get the y-intercept. Up here, on this form, you just looked, and you said, okay, it's -2, we put that there. This is different. This one is not 3, okay? 3 gave us the y value of the vertex, the k value. To find the y-intercept, you're gonna say, well, what is y when x is 0? Okay, so you have 2 times 0 plus 1 squared plus 3. Okay, this is going to be 2 times 1 plus 3, and that is 5. Okay, so you just plug 0 in and you work this out. And if you want to put this into your calculator, you can, but you should get to the point to where you don't need to. So this is 0 and 5. Now, once you get all three of these graphs, so you just do this in order, 1, 2, 3. Now we're going to come over here and we're going to graph it. -1, 3. There's my graph. X equals -1. That's a vertical line. That's the axis of symmetry. And it just goes straight down the middle of the graph. X equals -1. You have a y-intercept at 0 and 5, which means we are right here. Now the point symmetric to the y-intercept. Remember, here's the y-intercept. It is 1 unit away from the axis of symmetry. Therefore, on the other side, we have a point 1 unit away from that, and then that coordinate is -2 and 5. Okay, so we have our information graphed. Now, remember, the vertex should go in the middle of your table. That'll help you graph it, -1 and 3. Now, you really need at least 5 points, so I'm going to use my calculator. Okay, and I have 2 times x plus 1 squared plus 3. Go to my table, and I'm going to put -1, 3 right in the middle of my table, because I need to know what's going on above and below the vertex. So I have -2, -3, -4, and I'm just copying this down. And you just want at least 5 points. So I have these. I already have -2, 5, and 0, 5 graphed. Now I'll graph -3, 11, and then I have 1 and 11. So now I have 5 points. I can go ahead and graph it. And if you look at this, there are no x-intercepts, there are no roots, so you would just say none. We'll learn how later to find these. These are actually going to be called the solutions of the quadratic. This one would have no solution.